Hello, this is James Jopling with Shoppa's John Deere, and these are hydraulic components for our 2022 Check Challenge. Okay, our next component is called a hydraulic accumulator. And many of our hydraulic systems and over the entire all industries use this type of accumulator. There are multiple different types of accumulator, but this one is a hydraulic accumulator. The first statement is it's false if the pressure within the gas-filled bladder is never proportional to dampening of specific hydraulic system component. This chamber in here is going to be gas filled and utilizing dry nitrogen. If that pressure is low as far as your quantitative charge of dry nitrogen, then it'll allow that bladder to come all the way down, and hydraulic oil will enter this chamber, and instead of having a dampening effect with a little cushion, there's not going to be any dampening effect. Okay, now our next statement, an accumulator will reserve pressure, oil, volume as to where when a slight pressure diminishment is within the system, it will not provide compensation for such demands. That's false, because it will. You're going to have gas in here, in this area, and you're going to have hydraulic oil in this chamber at a specific pressure. When you have hydraulic oil pressure drop, then with the gas-filled area here, it's actually going to force this bladder down a little bit, forcing a small amount of oil back out into the system, supplementing the hydraulic system. Now next is an accumulator will allow a fluid or gas to pass through dampening. That's false. This is not a pass-through. This is just merely your oil will come in from this point right here and into this chamber. It does not pass all the way through. If the bladder within the accumulator is ruptured, it will still function properly. There again, if this bladder ruptures, then it's going to collapse totally, and you're not going to have any reserves back in this area, nor will you have any dampening effect. So that's false. This isn't a spring type of accumulator. That's true. A spring type, instead of having a gas within this chamber, which is dry nitrogen, it would have a spring and just a simple bladder that the spring would be pushing against, not gas. So that's true that it is not a spring type accumulator. Okay, our next component, it's a hydraulic component. This is a gear pump. Okay, the first statement, if a leak in the system occurs, the flow from gear pump will not remain constant at the constant drive RPM. Now, it's going to still remain whatever the engine is or whatever may be driving it. If that RPM remains the same, then the volume should remain the same from this pump. The next statement, a gear pump is considered a closed center hydraulic pump. That's incorrect. This would be considered an open center pump, whether it be for fuel, hydraulic oil, what have you. This would be open center pump. The next statement is false. The volumetric flow will not vary according to drive RPM. That's inaccurate. The faster it's driven, the more liquid it's going to move. It's going to pump faster, or pump at a higher rate. With any gear pump fluid system, a relief valve is necessary to maintain a constant system pressure. That's true. If you didn't have a relief valve built into the system and we're pumping oil constantly, we're going to increase pressure higher and higher and higher until something ruptures, something breaks. So we've got to have some type of relief in the system to maintain a specific pressure. And the last statement, this can be considered as an open center or closed center hydraulic pump. No, there again, this is only an open center. A gear pump is just that's an open center pump. The smaller tractors or mini tractors have an open center, meaning that you have a relief valve of which to maintain specific pressure, and not a closed center to where you have pressure and volume regulation. But anyway, that is all of which we have on the gear pump. Okay, our next component is an electro-hydraulic valve, which these are utilized in many industries. And this is to control hydraulic oil, and it can be used. There are some applications that we have in some valves that control pneumatics, air. But this one is for hydraulic. You're utilizing a coil, an electrical coil, to move the spool, which directs oil and then also moves the secondary spool, which will send oil to different packs or components, what have you, needs to be controlled. Now, the first statement, this type of valve is used to function pneumatic operations. There again, this is not for air. This is for hydraulic applications, with all the porting, everything which we have. Okay, the next is false. If electrical providence is diminished to the coil, there will be no notable directed hydraulic function performance. If this coil were to fail, then you wouldn't have any movement from this plunger, which therefore you would not have any movement to this spool valve in here. So if that coil fails, then whatever this is functioning will not work. Next, if directed hydraulic control function is not functioning properly, a possible cause may be loss of pilot pressure. That's true. You have pilot pressure, which actually comes in and assists in movement of the spool. Next, if the sump port is blocked to directed function, it may remain engaged even though the electrical providence to the coil is discontinued. That's true, because it's directing oil to whatever function that is, and even if this coil is de-energized and the sump, which is just the oil that comes back to the return to relieve it, if that port is blocked, then you won't have diminishment of the pressure within that function. So it may continue to function, whatever it may be. So that's true. And the last, if the return spring should fail, the directed hydraulic flow to the controlled mechanism will cause no issues. That's false. If this spring were to fail, then this spool will fall down. It'll actually travel down, and it can potentially keep that engaged function active continuously. It'll keep it pressurized. And that's all for the electro-hydraulic valve. Okay, our next component is a hydraulic cylinder. Very common, multiple applications throughout many industries. Okay, our first question or statement, this cylinder rod is within specification of 0.725 plus or minus 3/1000 of an inch. Okay, miking it we are well over 950 thousandths. So that's false. It is not within that specification. And the next statement is, this cylinder can't be used for single action application. Indeed it can. You can actually have, these are ports on each end, and you can have this piston rod in here, and piston, and you can have a vent on this end and just apply hydraulic pressure here, and that would move this in this direction, and then having potential just gravity, once the pressure is relieved here, come back down. So it can be used in single action. The next statement, if a hydraulic pressure applied is the same to the extend end of the cylinder piston and then applied to the retract end of the cylinder by reversing flow, the end result force will be equal bidirectionally. That's false, because you have to take into account the diameter of the rod and the surface area application for the oil. In one direction, you're going to have a greater surface area than you will the other direction due to the cylinder rod. If the cylinder rod is bent, it can be used for curved force application. That's false. If this rod is bent, this cylinder is essentially useless. And that is all of which we have for our hydraulic cylinder.